All right, synthetic division of polynomials. It's a type of shortcut that we can use when we're dividing polynomials, but we can only use it when the divisor is linear, okay? When it looks like this, x minus k. K can be any numeric value, okay? Now, I need you to notice this is linear, so x to the first power, it has to be to the first power, and our coefficient of x is the number 1, all right? So the way that you're going to set up synthetic division is you're going to put the k value on the outside, and then you'll draw this little L shape, and you will list the coefficients of all of your terms here across the top. So I'm going to do some examples with you here in a second. But if you don't have this note sheet and you want to take a screenshot or pause the video and write these steps down, you certainly can, or you can just work the examples with us. Okay, so over here on the right side is a problem that's completely been solved for us already. So I just want you to recognize a couple of things first before we get started. It says use synthetic division to divide this polynomial expression by x plus 3. So notice we are allowed to use synthetic division because this is x to the first, it's linear, and its coefficient is 1. The coefficient of x is 1. All right, now this format right here, x plus 3, remember that our divisor is in the form of x minus some number k. But this says plus right here, so how do I turn it into the form of x minus? Well, that's the same thing as saying x minus a negative 3, right? So in this problem, our k value is a negative 3. It's not generally, it will always be the opposite sign of this. If this says x plus 3, our k value is negative 3. If it had said x minus 3, our k value would be a positive 3. So we're going to take this k value right here, and we'll put it on the outside, and then we'll draw this little L shape right here, okay? Then we need to list out all of our coefficients. I want you to pay attention and recognize this first. We start with x to the 4th power, but I'm missing an x cubed term. We go straight to x squared after that. So it's important that we have placeholders for those missing terms. So the coefficient of x to the 4th is the number 1, so I place that right here. The coefficient of x cubed, because it doesn't exist, is the number 0. The coefficient of our x squared term is this minus 10, so we put a negative 10 here. Then our x term is minus 2x, so I put my negative 2 right there. And then I finish with a constant every single time, which in this case, it's a plus 4. So I put my positive 4 right there. Okay, so that's the setup. That's the setup that we're going to use every single time. Then we have these arrows drawn for us. So the first step that we're going to do is we are going to bring down whatever this first coefficient is and place it right here. It's the number 1. Okay, then we are going to multiply what is negative 3 times 1, and that gives us a negative 3. And then we always combine moving down, combining or adding. What is 0 minus 3? Well, that gives us a negative 3. And then we multiply again. What is negative 3 times negative 3? That gives us a positive 9. So positive 9 goes up here. And then we combine again. What is negative 10 plus 9? Well, that gives us a negative 1. So that goes down here. Then we multiply again. Negative 3 times negative 1 gives us positive 3. So that goes here in this position. Then we combine again. Negative 2 plus 3 gives us a positive 1. Then we multiply again. Negative 3 times 1 gives us negative 3. And then we combine again. We have 4 minus 3 gives us 1. All right, so there's nothing left for us to do. Now, what we have here, all of these values represent the coefficients of our solution. So whatever we started with, whatever value we started with, it was to the 4th power, whatever our degree was, our solution will always be 1 less than that. So I started with x to the 4th power. So our solution is going to be 1 x cubed minus 3x squared minus 1x plus 1. Now, what do we do with this final number right here? Well, this is our remainder. This is our remainder. And just like in long division, when we took our remainder and we put it over our divisor, we're going to do that again here. So it's plus 1 over our original divisor, which was x plus 3. Okay? So it's quite a bit faster than polynomial long division. Again, you don't have to use this method if you don't want to, but I think after you practice it a couple of times, you're probably going to want to use it. All right? So let's do some actual problems here. All right, here we go. 5x squared plus 1x minus 15 divided by x plus 2. Are we allowed to use synthetic division here? Yes, we are. This is x to the first power, and its coefficient is 1. So let's look at what the divisor is. It's x plus 2. That means our k value is a negative 2, right? It's always going to be the opposite sign. So let's do that setup. We've got a negative 2 here on the outside, and then we're going to draw our little L shape. Okay? Our degree is an x squared term. We have an x squared term. We have a degree of 2. So let's write down all of our coefficients across the top. We have a 5 for x squared. We have a positive 1 for our x term. And then we have a negative 15 or minus 15 for our constant. That's all we have. So what are we going to do? The first thing, we drop down our first coefficient. So we've got this 5 here. And then we multiply. What is negative 2 times 5? That gives us a negative 10. Now let's combine. 1 minus 10 gives us a negative 9. And then let's multiply. Negative 2 times negative 9 gives us a positive 18. So we put a positive 18 right here. Then we combine. What's negative 15 plus 18? That gives us 3. And remember, this last number is always our remainder. So our original problem started out as a quadratic, x squared. So our solution, our quotient, is going to be x. So this is 5x minus 9. And then we have our remainder, plus 3 over x plus 2. Remember, it's always our remainder over our divisor. And that is our solution. Okay, let's do another one. X to the fourth minus 3x cubed minus 7x squared minus 11x minus 20. If we were going to use polynomial long division, that would take a while to break up. Divided by x minus 5. I'm allowed to use synthetic division because this is linear. It's x to the first power, and its coefficient is 1. So what is our k value? Our k value is a positive 5. See how it says x minus 5? So it's always the opposite sign. It's going to be a positive 5. So let's go ahead and list that out. We've got this 5 right here, and we draw our L. Okay? Now, what are all of our coefficients? X to the fourth power has a coefficient of 1. X to the third power has a coefficient of negative 3. X squared has a coefficient of negative 7. Our x term is negative 11, and our constant is negative 20. I don't need any placeholders because we go straight from x to the fourth, x cubed, x squared, x to the first power, and a constant, okay? And you do always want to finish with a constant. If you don't have a constant, then make sure you put 0 on the end. But we've got ours, so no big deal. All right, bring down the number 1 first. We bring down our 1. Now let's multiply. 5 times 1 gives us 5. And combine. Negative 3 plus 5 gives us 2. Now multiply. 5 times 2 gives us 10. Now combine. Negative 7 plus 10 gives us 3. Multiply again. 5 times 3 gives us 15. So we'll place a 15 right here. Combine, and that gives us 4. Negative 11 plus 15 gives us 4. Multiply again. 5 times 4 is 20. Place a 20 right there. And when we combine negative 20 plus 20, we get 0. So our remainder for this problem is 0. We have nothing left over. These polynomials divide each other evenly. So because we started out with x to the 4th power, our solution starts out as x cubed. So this is 1x cubed plus 2x squared plus 3x plus 4. And of course, you do not have to write your 1 coefficients if you don't want to. If you see an answer on a test or written in a textbook, something like that, you won't see the 1. But it's an understood 1, but it's not incorrect if you write it down. All right, let's do one more problem. X to the 3rd power minus x minus 29 divided by x minus 6. Are we allowed to use synthetic division? Yes, we are, because our divisor is linear and its coefficient of x is 1. So what is our k value here? Let's use purple this time. Our k value is a positive 6. So let's put that 6 on the outside and draw our little L shape. All right, our highest exponent is 3, so this is x cubed. This is 1x cubed. Now, I don't have an x squared term here. I go straight from x cubed to x. So I need a placeholder. I'm going to put 0 for x squared, and then negative 1 for my x value. Remember, there's an understood 1 in front of any variable. So minus 1x, and then we have our constant of minus 29 or negative 29. Okay, so remember, we want to drop down our 1 first, and then we multiply. I'm going to go ahead and draw the arrows in case you guys want to put them on your paper. 6 times 1, remember we're going to multiply. We're going to go diagonally. We multiply. 6 times 1 gives us 6. And then we combine or add going straight down. 0 plus 6 gives us 6. Then we multiply again. 6 times 6 gives us 36. So we put our 36 right here. And then we combine or add going down. Negative 1 plus 36 gives us 35. 35. Okay, then we multiply again. 6 times 35. Let's do that over here. 35 times 6. That's a 0, carry the 3. 18 plus 3 is 21, so 210. 210. And then we want to combine or add going down. So 210 minus 29. 210 minus 29. 10, 9, 81. 181. So 181 is our remainder. So remember, because our dividend started out as an x cubed, our solution is going to be quadratic, an x squared. So we have 1x squared plus 6x plus 35. And then, of course, we have plus our remainder of 181, which is being divided by x minus 6. All right, hopefully you like using that synthetic division shortcut.